Welcome back to my kitchen. Today we're going to do an experiment where we look at solar insolation and how the angle of the sun affects the amount of energy that reaches the surface of the earth. I have on my face a light that I'm using to sort of simulate the sun. And if I hold up this globe, which we're going to use to represent Earth, you can see that this part is receiving the most direct sunlight. And this part, because the Earth is curved, is receiving less direct sunlight. And we're going to use this experiment to measure that effect. For equipment, I have my protractor for measuring my angles of the sun. And I printed it from the internet and I went ahead and marked all the lines that I needed, all the angles I needed. So I have a 90, a 60, a 45, and a 30. So there's my protractor. I'm going to tape that down perpendicular to the wall as best I can get it. And I'm going to use these two sheets of paper that I taped together. I drew two parallel lines. It doesn't really matter how far they are apart. It doesn't really matter what units you use as long as you keep it uniform throughout. So I made these 4 inches apart. And I'm going to use that to project my sun at different angles and mark the locations. All right, my sun, since I'm using my cell phone, is this toilet paper roll and a flashlight, and the toilet paper roll just focuses it into a narrow beam. I'm going to make sure my flashlight is parallel to the tabletop, and I'm going to go up here, make sure I'm 90 degrees with my protractor at the bottom, and I'm going to mark the diameter side to side. Now, top to bottom, I've got my parallel line, so I don't need to mark anything there. So then I'm going to move to 60 degrees. I'm going to mark that. Let me erase a couple of lines that I drew already. But anyway, I got to keep these close together so I don't run out of space. So I'm going to get my 60 degrees according to my protractor, try to hold my flashlight parallel to the tabletop and at the appropriate angle. And I'm going to mark my ellipse. Notice now I no longer have a circle, I have an ellipse. I'm going to mark that one. Then I'm going to go 45 degrees. Again, make sure that the top and the bottom of your light circle line up with your parallel lines. I'll erase a couple of marks I already have there so I don't get confused. And 45 degrees is about right there. My top and bottom are lined up, so I'm going to mark there and mark there for my ellipse. And then last of all, 30 degrees. I've got to get my flashlight a little closer. And it looks like I'm going to have to write on my wall just a tiny bit because my papers aren't long enough. But let's see here. Remember, again, the key is to get the top and the bottom the same every time. So got to make sure my circle or ellipse this time touches the top and the bottom. Mark this side of it and then mark this side of it. Oops, I should have a third piece of paper so I don't have to mark on my wall. But you can do it differently. You could make a smaller measurement this way, and then your circles and your ellipses wouldn't be so big. Now I'm going to take the measurements this way. This was my circle. This way was my 60-degree ellipse. This way was my 45-degree ellipse. And this last one, which goes all the way over to here, was my 30-degree ellipse. And so I'm going to measure. I already know the length here because it's the same, the diameter here. I'm going to measure, of course, the circle is going to have the same diameter side to side as it does top to bottom. 60 is going to be an ellipse. 45 is going to be a bigger ellipse. And 30 is going to be a bigger ellipse. And you're going to use a couple of mathematical formulas to determine the area covered by the, quote, sunbeam at different angles, and that's going to, of course, imitate how the sun actually strikes the spherical Earth, because it's going to the curve of the Earth is going to make the sun strike at a different angle depending on where you are on the planet.